Hi, good morning. This is Irv Shapiro of the Dr. of X channel. And today we're going to talk about magic, about illusions, about things that seem impossible. Now, we're not going to concentrate on prints of magical tricks. This happens to be called an infinity cube because if you look at it closely, it appears to have no beginning and no end. Fascinating print, relatively easy to print. But instead, we're going to talk about things that you really can only produce on a 3D printer using a layer by layer process. Those processes are called additive manufacturing. And the ability of 3D printing of various materials to revolutionize the world of manufacturing is fascinating and also just a lot of fun. So stay tuned and let's learn something together. Okay, let's get right to it, and we're going to look at some of these seemingly impossible prints. We're going to start with a child's toy. So this is a butterfly. Printed flat, nothing very special about it. You can print this on pretty much any 3D printer at the right size. You can print this on the $180 MP Select Mini from Monoprice. Now this was printed on a Prusa, so if I flex this print bed, the print will then come up, and this is magical. Look at this. This is a completely flexible butterfly with a whole bunch of little hinges in here. Now, I didn't put this together afterwards. I didn't print each piece and snap it together. I printed it directly on my printer and picked it up off the printer. Let's look at some other interesting prints. This is a pretty simple print. This is a ball, and it's a box, but the ball's in the box and it won't come out. So how did I get the ball into that box? Well, I didn't print the box separately and glue the pieces together with the ball inside. This printed directly on my printer. This happened to print on my Ender 5. I lifted it up and the ball was inside the box. So how is that done? How is that even possible? Let's look at another example. Here's a small one printed on the Prusa, a big one printed with a 1mm nozzle. That means it prints with much thicker lines, and you can see the lines. The lines are not very pretty in this, but this printed very fast. And this elephant is able to lay down, to stand up. The head rotates. I printed one of these at a higher quality for my grandson in Florida. He loves it. How do you do this? Once again, this was not assembled afterwards. This was printed lying like this on the printer. I lifted it up and it was ready to go. Now, you think this technique is just interesting for toys? Well, on Thingiverse, and there's a link down below, there is a link to an application on Thingiverse. Thingiverse is a place you go for 3D prints. In this case, it's basically a program you use to design hinges. You need a hinge of a particular size, of a particular width, with a certain number of holes. Just design it on Thingiverse, print it in place. And you never have to worry about the pin coming out because the pin is integrated into the hinge. This wasn't two hinges snapped together and the pin inserted. This was printed in place. So I'm going to show you now with a very simple example, the example of the ball and the box, how this process works. So let's turn our attention to the computer and we'll go into Tinkercad, a very easy to use computer-aided design program designed for young children, really. It's taught in the 3rd and 4th grade in elementary school. And we'll see how you could design this particular model. And using similar techniques, a bit more sophisticated, but similar techniques, any of the prints that we're printing here. Okay, let's turn to the computer. Okay, now we're going to open up Tinkercad and we're going to design this objects. Now this is not a Tinkercad tutorial, but if you're familiar with Tinkercad, you can follow along and probably reproduce this without any difficulty. Instead of starting with a basic shape, I've already created a box that looks like this outside box. I did that by taking a cube and then taking rectangles, turning them into holes, and using them to cut out the sides of this box. So we're going to go to my part list. In the case of Tinkercad, you can save parts away, and we're going to drag that box onto the screen. Next, we're going to take and put a ruler on the corner of that box. Let's get that right on the corner. And then we can see that this box is 40 millimeters high, 40 wide, 40 deep. The sides are 5 millimeters each. That means the inside dimension of this box is 30 millimeters. So if we take and create a sphere and we make it bigger than 30 millimeters, it won't be able to fall out. So let's see how to do that. We're going to go to Basic Shapes. We're going to drag a sphere onto our work plane. We're going to make that 35 by 35 by 35. And now we're going to select both of these objects. We're going to go to Align, and we're going to align them on the center in each of the 3 axes. This axis and this axis. So what we have now, let's dismiss the ruler, is we have a sphere inside a box. Now, creating a sphere inside a box in a CAD program is easy, as you just saw. The magic is printing it. So how is this really going to work? Well, if we look at the bottom, we'll see that the sphere is resting on the bottom of the work plane. But if we rotate it around, you can see right here, we rotate it around again, you can see here, and we rotate it around again, you can see here, then you'll see that it is never touching the sides. It is just suspended in the middle. Now, how are we able to print that? Well, 3D printers print in layers. So if we think about the first layer, let's visualize the first layer. We're going to print a square, and there's going to be a little dot where the bottom of the sphere hits the bottom. And as we move up, we're going to continue to, in essence, print the outside of this cube, and we're going to be printing the sphere inside as a separate object. So we're going to load this into Cura, into a slicer that will prepare it for printing, and look at a simulation of how it will print to make that even clearer for you. So we're going to go ahead and do an export of this object. Now we will close Tinkercad, and we'll open up Cura. In Cura, we're going to take and make this a little bit bigger. And then we're going to load in our cube, ball in a box. I'm going to select it. I'm going to scale it up to about 300%, make it a little easier to see. Now, once again, if we rotate, we'll see that the red surfaces are touching the build plate. So those are all touching, and just the very bottom of the sphere is touching. If we rotate it around, we can see it's not touching anywhere else. So now, let's take and slice that. That slicing it converts it into the individual layers that are going to print. I'm going to click on Prepare. It'll take just a moment to slice. And now let's go ahead and look at it as a layer view. And we can see here at the very first layer, it's printing a square with a little dot. And as we go up, we can rotate it here, make it easier to see. As we go up, the sphere inside is never touching the outside. It's just printing them at the same time. And that's the magic of a layer by layer process. When you build a house and you have a window in the house, you're using very much the same technique. You're laying the bricks, then you're going the bricks up the side, then you're going the bricks over the side, over the top, and you're able to include features in the middle that are supported from somewhere else. So layer by layer manufacturing allows us to print a wide range of objects that could never be manufactured easily before. This would have had to been made in two parts and glued together. There's no gluing involved here. Okay, let's go back to our desk, look at a couple other models, and summarize what we've learned. Okay, now that we've learned how to design and print a sphere inside a box, we can extend this principle to any type of articulated or hinged product. Because in essence, if instead of printing a box, we print a ring, and then we take and we print a cylinder going through the middle of that ring. When we rotate the cylinder, we've now made a hinge. And anything we attach to this cylinder will rotate. And the hinge can also potentially rotate or stay stable. So this is the concept that's used to create the butterfly. Each of these corners here is a little circle, and on the butterfly wing segment we have a hinge, so it's able to move side by side. And because we've left it fairly loose, it also is able to rotate, move this way a certain amount. The same thing applies to this traditional hinge. You can see how that would work the same way. It applies to the hinge in this gripper, another magical print that comes right off the print surface and works. And it even applies to our elephant's legs. Now, there's an interesting and important concept we have to think about, and that is the concept of clearance. Each of these hinges has a certain amount of space between the outside walls and the rod in the middle. That space is called clearance. Now, on this sample, we have a clearance of 0.6 millimeters. That works great, a little sloppy. 0.5 works well, a little sloppy still. 0.4, pretty tight and works well. 0.3, it's fused together. It's not working. Why? Because when we think about clearance, we have to think about the accuracy of our printer. How accurately can it put down a bead of plastic? That accuracy is called tolerance. If we make the clearance too small, less than the tolerance or the typical tolerance, at times the plastic will touch together and will fuse. Okay, now that you've learned how to create and print these wonderful, seemingly impossible objects, I hope that this has been interesting for you. It's been a bit of fun. Share this video with lots of people. People find it fascinating to look at these various objects. If this was useful to you, please give me a thumbs up, subscribe to the channel, and most importantly, let's continue to learn things together.